Chapter 2, number 80. To celebrate a victory, a pitcher throws her glove straight upward with an initial speed of 6.5 meters per second. A. How much time does it take for the glove to return to the pitcher? And B. How much time does it take for the glove to reach its maximum height? So we're going to draw a quick picture. It's going to look a lot like the juggler problem because it's almost the same problem. We throw this thing, and I'm going to stretch these out across this horizontal distance as if she had thrown it to the side, although it says she throws it straight upward. I'm only doing that to make the picture a little clearer. So imagine in your head that it does this, but we're going to say it goes up to some maximum height and then returns back down. And it leaves her hand with some with a known initial speed of 6.5 meters per second, goes up to its maximum height, and then comes back down, and we know that it is heading downward with that same speed. We know that throughout the problem it is accelerating at g downward. What we do not know is its maximum height, and we don't know the time, but I am going to name these things. So I'm going to say that this moment is t equals 0, and this moment is t equals time of flight, and by the symmetry of free fall, that means this moment, which I'm going to call t1, is 1/2 the time of flight. So part A says find how much time to get back, so that's tf, and part B says how much time to get to the maximum height, and that's t1. So I just need to find those two things. One of the things I can use, perhaps, is that at both the start and finish, it's at y equals 0. So I could, for instance, use the equation that y equals y0 plus v0t plus 1/2 at squared, and then I can throw in the things I know, which is it ends at 0, it starts at 0, it has some initial speed that I know, it has a time that I'm looking for, and it has an acceleration which is minus g, and that time again. And I now just need to solve for the time. So I polish this a little bit. I say 0 equals v0 tf minus 1/2 g tf squared, and then I use the algebraic trick that this appears in both terms, so I can factor it out once. And what I'm left with over here is v0, and what I'm left with over here is 1/2 g tf. And then I'm going to use a further algebraic trick called the zero property, that if two numbers multiply to 0, then at least one of those numbers is 0. So either tf is 0, or v0 minus 1/2 g tf is 0. But one of the two terms must be 0. Right? This is this guy, and this is this guy over at the red. So, what does that tell us? Well, this is true but weird. We asked the equation to tell us when is it back to a height of 0, but math doesn't really know what we mean back. We're asking when does it have a height of 0, and it definitely has a height of 0 at t equals 0. So this is when it's thrown, which is logically not the final time, but the initial time. And then over here we can just solve this, and we can say, well, let's add tf 1/2 gtf to both sides, and then we would end up with 1/2 gtf equals v0. So tf will be 2v0 over g. If we plug in some numbers, we'll have 2 times the initial speed of 6.5 meters per second over the 9.81 meters per second squared for g, and we get 1.32 seconds. So that would be our time of flight. And then they ask us for the maximum height, time to the maximum height, but that's almost trivial because t1 is 1/2 tf. So it's 0.663 seconds. And we'd be done. I'm going to solve it an entirely different way just to see that we get the same answers. We could tackle this a different way. So let's rebuild. Like that. And now what we can say is we're going to still have our same definitions, and we're still looking for TF and T1. But now what we're going to use is we're going to say, well, we have this initial speed that we know, and then at T1, which we don't know, the velocity is 0. And here at the time, the velocity is the given 6.5. So we could also use something along the lines of v at any time is v is initial plus ay times t. So at the highest point, we get 0 equals v0 plus minus g times t1, which allows us to say that gt1 is v0, or t1 is v0 over g, which is 6.5 meters per second over 9.81 meters per second square, which is 6.5 over 9.81, 0.663 seconds. And then we know that TF is going to be twice T1. We get 1.33 seconds. In other words, the same answers as expected. Which of those is easier? Well, maybe this one. I had a story from my father that taught me that the shortcut you don't understand is never faster than the long way that you do. But if this occurred to you, it might be a little bit faster. But either one is perfectly fine.